Welcome students to another lesson. And today we are going to start to try and master this skill of dimensional analysis in our 5.4 textbook lesson about converting rates. So I'm going to ask you to pause here, but before you do, let me actually go ahead and start scrolling down a little bit. This list is a little long, so I'm going to try and show you the most I can of it. And then I may have you copy a little bit more at the bottom in a second. So pause here and go ahead and copy what you see. Nice. So again, we're learning textbook lesson 5.4, converting rates. And our essential question is, how can we use dimensional analysis to help us convert between different units? Remember, dimensional analysis is helping us use our units to set up the math problems. So we have this really long list of conversions, and some of these you may have known, some of these you may not. I'm going to add a couple more here at the bottom. Just as I've learned, some students are missing some as well. So if you did not know, 1 mile does equal 5,280 feet. I'm always surprised by this one, but 1 hour does equal 60 minutes. 1 minute does equal 60 seconds. And some other ones. 1 kilometer is equal to 1,000 meters. And leave a little space before you copy anything else here. I'd say actually leave a full thumbs width before copying, so you know which students I'm talking about, you students who love to write so small and so tight. You want to leave space on this page because there is a really good chance there's a conversion you didn't know that we're going to have to add in here later. So once again, please leave space. Okay, so jumping into the problem, that was just our conversion chart to start looking at. And now we actually have our directions on how we use dimensional analysis. And remember, we've been practicing this skill for the first 3 units, but this is the first time I'm really giving you the direct lesson on how to do it, and it's going to utilize more than one conversion. That's important to recognize. We've been using a single conversion at this time, and using dimensional analysis allows you to actually use multiple conversions at the same time. So go ahead and pause here and copy what you see. I'll scroll down just a little so you can see the whole thing. Okay, go ahead and pause. Okay, welcome back. I hope I gave you enough time there. I think that may have been quick. I'm going to need another slide. So a lot of dimensional analysis, you kind of need some space to do this stuff. So you do want to leave a little room when you show these math problems because we set them up from left to right. Yep, just the way we read. Okay, so read the sentence. Again, who would have thought that had to be written down? So we're in a skydiving class. Lily is flying through the air at 176 feet per second. Okay, and then the question we're looking at here, we're going to box our question, is how many miles per hour we need. And I'm going to kind of stress where our ending units are going to go and where our beginning units are. So the hardest part of dimensional analysis is recognizing the starting units and the finishing units. And then we actually create the fractions or the ratios in the middle of this to get to the ending unit. Okay, so we're going to have to create a rate out of 176 feet per second, and we do that by writing 176 feet. And remember, per second means divided by 1 second. And our goal, yeah, I'm showing it way on the right side here, is to turn our units into miles per hour. Okay, so we have to convert feet into miles, and we have to convert seconds into hours. And this may take multiple conversions. So I'm going to start in my question section listing the conversions we likely will need from the conversion chart on the very beginning of this note. So we're going to need a conversion that gets from feet to miles. Is there a conversion we know for that? Yeah, you're right. 1 mile equals 5,280 feet. So there is a conversion we can use for that. Is there any conversion from seconds to hours on that chart? Yeah, you're right, there isn't one. So I like to show this as 2 conversions, and you may learn in class that we can actually create a different conversion to add to our conversion chart to make this a little simpler next time. So we're going to have to change 1 minute, which equals 60 seconds, And then we also need that 1 hour equals 60 minutes. And with these three conversions that were given to us from our conversion chart, and we will eventually need to memorize these, those conversions I think are going to help us get to miles per hour. So let's see. I don't like feet on the top, so we're going to start with just a distance conversion. I don't like feet on the top. So if I want to get rid of feet as a unit, I need a feet in my denominator. And is there a conversion from feet into miles? Yes, there is. So we can put the mile up on the top there. Okay, so I believe those are going to reduce those units correctly. And then we need to have a conversion from seconds into hours. There isn't one of those, so we're going to get seconds into minutes first. Okay, but that doesn't get us our ending unit that we want. Oh, wait, did I set that up correctly? No, because seconds was on the denominator. Therefore, I need a seconds on the numerator. But do we have a conversion from seconds to minutes? You're right, we do. Okay, and then minutes isn't what I'm supposed to have in my denominator. I actually need to get rid of my minutes and convert that to hours. So let's look over there. We got, do we have a conversion for that? We do. So if minutes is on the bottom, I need a minutes on the top. And we can turn minutes into hours. Okay, so notice I've only put the units in here first. There's no numbers at all just yet. We're just using the units to start with. And now that we have our units, let's make sure they're going to cancel off correctly. So feet divided by feet, oh, those reduce. And that only leaves miles as our only distance unit. The seconds reduce. We have a second on the denominator and a second in the numerator. So those become the invisible one. And we have minutes on the denominator and minutes on the numerator. So those two become the invisible one. And the only unit we have left is hours. So it turns out that dimensional analysis helps us make sure we've set the problem up correctly before doing any mathematical calculations. So if we put our numbers in the right location on these fraction ratios here, it'll end up as miles per hour as our final unit. So our first ratio here is going to be created from our first conversion. What number do I need to put in front of mile? Yeah, it's the number 1. What number, according to our conversion, goes in front of feet here? Yeah, it's 5,280. And what number goes in front of seconds for my second conversion from seconds to minutes? According to our chart here, we need to use 60 seconds for 1 minute. And then for that final conversion there, what number goes in front of minutes? We got a 60. And what number goes in front of hours? 1. Okay, so we've set up our problem. And again, remember this is a chapter that does love to use calculators. So what we will be allowed to do is you're allowed to multiply every number on the top divided by all the numbers on the bottom. Yeah, you're right. But I can actually start doing a couple reductions here, I believe, to make the math easier. But I don't want to confuse anyone in the lesson, so we're going to finish this part of the lesson in tomorrow's class. So let's just go and set up our next problem for us. So for problem 5 here, if you don't mind, pause the lesson right now and go ahead and copy down what you see. Awesome, welcome back. So we're talking about the giant tortoise's pace. It turns out this giant tortoise can walk 900 feet per hour. That's going to be the starting units we have. We have feet per hour. And I'm going to write that on the far left. Over 1 hour. And our ending unit we're trying to get to according to this problem. Well, let's box our question. And it wants us to get to centimeters per second. So we need centimeters over seconds to end with. Okay. We may need multiple conversions again. So let's go to our conversion chart and let's double check it. Is there a way to convert feet into centimeters? You're correct, there is not. So we actually have to make two different conversions here. We first have to say 1 foot equals 12 inches. Computer had some interesting challenges there right now. There we go. And then we have to convert 1 inch, which equals 2.54 centimeters. And these are all coming from that conversion chart. So that's going to get us feet to inches and then inches to centimeters. That should, yep, that'll work. And then we have this hour problem again. So we need to get hours into seconds. And that's really similar to what we just did. We have 1 hour is how many seconds? Let's try and speed this up a little bit. What is 60 times 60? Yeah, so 1 hour has 3,600 seconds. So we can add that to our conversion chart to speed these lessons up, or this dimensional analysis. And if you don't understand how 1 hour is 3,600 seconds, please write a question down about that and I will answer it in tomorrow's class. So I'm just going to start setting this problem up. And again, we'll do our math in class tomorrow. So we don't like feet in our numerator. So we need to get rid of those feet. And if we have feet in the numerator, we're going to need feet in the denominator. And do we have some conversion from feet to centimeters yet? No. So we have to use this first conversion. We need to get feet turned into inches. And then we multiply it by another. And inches is not the final unit we want here. So we have to get rid of those inches. And if we need to get rid of the inches in the numerator, we need inches in the denominator. And lucky for us, we do have a conversion. 1 inch is equal to 2.54 centimeters. So we can get inches into centimeters. And then let's just make sure our lengths have been correct. The feet are going to reduce. The inches will reduce, and the only unit we'll have left is centimeters. That's perfect. And since I just taught you one more conversion here in the bottom of 1 hour is 3,600 seconds, we have one more ratio here. We don't like hours in our denominator, so we need hours in the numerator. And there is a conversion from hours to seconds. So there we go. So if we cross out our hours, those do reduce down to the invisible 1, and the only unit we'll have left is seconds, which is what we needed in our denominator in the answer. So now we just start plugging the numbers in, and this is a dimensional analysis is again a way to make sure you're doing your math correctly before you have to multiply or divide anything. So what number goes in front of inches in our conversion from feet? You're right, it's 12 inches is 1 foot. So again, we always double check our conversion to make sure we're putting the numbers in the right spot with the correct unit. In the second ratio here, we have 1 inch is 2.54 centimeters. And in this final conversion here, we have 1 hour is 3,600 seconds. And again, we're going to do our math together here. So you can just leave some space so we can actually do the math. The final page of this slide is example 3. So please copy down what you see. And I'm going to actually do these entire example 3 with you in the class, if you don't mind. So thank you, students, for copying down what you saw and learning some dimensional analysis in this video lecture today. If you have any questions, please keep on writing them in the question column. It's okay to add to your notes. You can't take away, but please add as much as you'd like. Hey, welcome, students, or thank you, students, and I'll see you tomorrow.